Welcome to my third playlist on Waves and Thermodynamics for my new preliminary course series. So let's have a look here at this equation, or series of equations. So you got the wave velocity equation to find the frequency of a wave and the wave number. So what are those variables there, and what does each of those letters mean? So K is your wave number and lambda is your wavelength. So the wave number of a wave has an inverse relationship to the wavelength, and you can see that by K equals 2 pi over wavelength. Now let's have a look at what T is. T is your period in seconds, and F is your frequency, which is in hertz. So this equation is T equals 1 over frequency. So the period of the wave has an inverse relationship to the frequency. Now let's have a look at the third equation. The speed or the velocity of a wave can be calculated using the following equation: V equals F lambda, which V is speed of a wave in meters per second, F is frequency again in hertz, and lambda is wavelength in meters. So let's answer a question here now. So a wave has a wavelength of 0.25 meters in a period of 4 times 10 to the negative 4 seconds. Calculate the following: A, velocity, B, frequency, and C, wave number. Now, can I just mention now, you can't sometimes, or most of the time, you can answer it logically A, B, C. Sometimes you can't, and in this instance, you can't. So let's have a look here at what you can do first. You can find the frequency by using F equals 1 over T. 1 divided by 4 times 10 to the negative 4 seconds, and your frequency is 2,500 hertz. Now, to find the velocity, which is A, you do V equals F lambda. 2,500 hertz is what we just found out, times 0.25 meters, and the velocity is 625 meters per second. Now, to work out the wave number C, you just do K equals 2 pi over wavelength, and substitute where wavelengths fittingly appropriate at the bottom, and you'll get K equals 25.13 per meter. Okay, let's look at an opera singer sings at 300 hertz. Find the wavelength of sound vibrations. So first you need to rearrange the formula to look like V equals F lambda. Now divide by F, or frequency, on both sides, and then it cancels out. And you got wavelength equals V over F, and you've got 340 meters per second divided by 300 hertz, and you'll get your wavelength as 1.13 meters. Alright. Waves spaced at 20 meters apart hit a beach at 8 seconds intervals. Find the period, frequency, and velocity of the waves. So let's have a look here at what we can do first. Our period is already given to us in the question, which is just 8 seconds. Our frequency is 1 over the period, so we just do 1 divided by 8 seconds, which is frequency as 0.125 hertz. And velocity equals V equals F times lambda. V equals 0.125 hertz times 20 meters, which is given to you in the question, and your velocity is 2.5 meters per second. I hope you enjoyed watching this video. In class, we're going to do many more of these questions, and we're going to be making predictions, and maybe looking at graphs. I'm going to ask my followers, if you'd like more of these videos, please subscribe, or just continue watching a playlist, or look at the Waves and Thermodynamics playlist. Thanks for watching.